All right, this is section 5.2. You guys have a quiz Thursday over sections 5.1 and 5.2. You will be allowed to use a calculator. If you don't have one, you will not be able to complete the quiz. So make sure you have one or borrow from somebody and you know how to use it. In class tomorrow, I'll go over the 5.1 and 5.2 homework that you guys worked on previously and then what you're doing tonight. Wednesday we'll review, and then Thursday we'll have our short quiz, okay? So this lesson is talking about, it's an exponential function, but it's the e. So look at your calculator. Everybody see if you can find the little e. It should be like, it's generally with the ln, the log button. Everybody see it? Yes or no, maybe? Looks like this. E to the x. The letter e is similar, not similar, but the way that we, like if you hit pi in your calculator, it's 3.141519, E is an irrational number like that. This is how E is derived. I know you guys don't care about this. If you notice, this is part of our interest formula, correct? Remember that? But look, every time you evaluate the interest, that section of the interest formula, and you put it in your calculator with what all of these numbers, base 10, what do you see about the value of E? It's about the same every time. So that's how it's derived. It's just an approximation, so you will use your calculator. You don't plug in 2.17, you just hit the E button and then we're good to go. So this is what the natural exponential function looks like. Everybody see here? It's similar to our log function, or our exponential functions. It's just the base is always that letter E. Okay, so to evaluate it, let's practice. In your calculator, hit the E button. What is E to the third power? 20 point, it says round to 5 decimal places. So what? 0.8554. Okay. So once we know how to do this in the calculator, like here, you're going to hit 2, then hit the E button, and then raise it to the negative 0.53. Do not use the minus sign, guys. It has to be the little negative. What do y'all get?
1.177.
1. Say it again. 1.1.
7721.
Something like that. You guys good? You get that? We okay? All right. We need to know how to do this in our calculators. What about here? E, and then just type 4.8. What do we get?
121.51042.
Okay. This Apple Pencil is so cool. All right, how do we feel? We all right? Okay. No, good. All right, now if we're going to graph, I want to just practice inputting here so you guys understand. I'm going to tell you here to use -2, -1, 0, 1, and 2. All right? If you have to graph, you need to be able to approximate. So if I evaluate this, I have e to the -2. What do you guys get? About. Give me 2 decimal places. 0.14. Agreed? Okay. What if I have e to the -1? What are you guys getting?
0.37.
0.37. All right. E to the 0. It should be what? 1. E to the 1. 2.72. And then e to the 2.
7.39.
7.39. Okay. We did not just evaluate that function. We evaluated e to the x. I just want to show you something. So if I asked you guys to graph this at -2, you'd go to like 0.14. Do you know exactly what that is? No. It's closer to the 0 than it is to the 1, but just give an approximation. So then we have at -1, it's 0.37. It's a little higher. And then at 0, it's 1. And then at 1, it's 2.72. So it's a little closer to 3. Whoops.
7.39.
So it's a little closer to 3. And then at 2, we're way up here at 7 point something, right? Okay, so if I connect my dots, it's a nice smooth curve. It's our exponential function. Is that a growth or a decay? It's a growth. It's getting bigger. What do you guys notice that it gets really, 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 really close to but doesn't touch? The y-axis, right? 0. All right, so now we're going to evaluate the function that they gave us. I just wanted you guys to compare. E to the negative x. So when I plug in -2, I have e to the negative -2, which is what? Positive 2. So what is that?
7.39.
7.39. All right, so now at -1, I have e to the negative -1 is
2.7.
2.7. And then I have e to the 0 is 1, right? And then for positive 1, I have e to the -1, which gives me 0.37. And then e to the -2 gives me 0.14. What do you notice about these numbers?
It's smaller.
They get smaller. What are they in comparison to the initial equation we did?
They're opposites.
They're opposites. So here, all you're saying is -2, it's going to be up here. -1, it's about here. And then 0, and then here, and then here. So on your homework, when they tell you to graph, and I only gave you a couple to graph, what I want you guys to do is to be able to approximate. Some of you are like, how am I supposed to graph this? I need you to show me that you know that 0.37 is in between 0 and 1. It's not up at 10. You guys understand what I mean by that? So just understand that graphs are going to look different depending on negatives, positives, that sort of thing. But everything you do with e, the natural log e, is going to give you a decimal. So just be aware of that. Here, I'm not going to go through this whole thing, but if I told you guys to evaluate from -2 to +2, in your calculator you would say 3 and then hit E, and then in parentheses you would say 0.5 times -2. What do you guys get? Let's make sure we know how to do this. Put your exponent in parentheses. It's 3 and then hit E, raise it to the 0.5 times -2. Everybody agree?
I got 0.66.
Okay, let's do it. 3 different answers. It's net. You got to use the negative key, not the minus sign. So I got 1.1 about. Okay. Again. Okay. All right. Here we go. Okay. So here we go. We're gonna say 3e, and it's to the 0.5 times -1. Okay. My bad. What is that?
1.8.
3. What are we getting? What are we getting? What is it?
1.8.
Okay, 1.8. Good. Okay, so now I have 3e to the 0.5 times 0. What's 0.5 times 0? 0. So e to the 0 is 1. 3 times 1 is 3. So here I have 3e to the 0.5 times 1. What does that give us?
4.9.
4.9. And then I have 3e to the 0.5 times 2. And I get what?
8.2.
8.2. All right, so what kind of a function is this? Is this a growth or a decay?
Growth.
It's a growth. Okay, so look, is this a growth or a decay, guys?
Growth.
It's a growth because it starts out little and gets bigger. Does everybody see that? And then if you were going to graph that, you would just do that. Okay, so here you guys have an equation. It's a word problem, but it says an infectious disease begins to spread in a small city with a population of 10,000, blah, 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 blah. Here is the equation. They want to know how many people are infected after the time 0. So what do they want me to plug in? 0. Where in this equation do they want me to plug in a 0? For the t. So your problem looks like this. Divided by 5 plus 1, 2, 4, 5e to the negative 0.97 times 0. Okay? To do this in your calculator, you guys have to be real careful. If I were you, let's try it first in steps. Let's do just the denominator. So in your calculator, you're going to hit parenthesis, right? 5 plus 1245 E, and then in parentheses you have 0.97 times 0. Close that little parenthesis, and then close the big parenthesis. Just do the denominator. Don't even worry about the numerator yet. We'll practice doing it all at one time, but let's just practice this way. So I have 10,000 on top, and then what did you guys get for a value in the denominator?
1250.
All right, we got 1250. Now, when you divide 10,000 divided by 1250,
Is 8.
what'd you guys get? 10,000 divided by 1250. Come on. What'd y'all get?
9.6.
8. Do it again. 10,000 divided by 1250. Pay attention to what I'm doing, please.
8.
It's 8. Now, most of you should be able to do this step all at one time in your calculator. You need to practice this because if you round too many times, if you do just each piece separately and you round, you might end up at an answer that's further away than it needs to be. So we'll practice that tomorrow. If you guys need help, I'll ask you, whatever you need help with, we can do that. But what we're going to do now is find different values for different given times. So let's remind ourselves, our function was 10,000 on top, right?
Yeah.
Over, what was the bottom? 5 plus 1245 E
Negative 0.97t.
0.97 T. What do they want me to use for T now?
1.
Look, what do they tell you guys? Everybody, look.
2 and 5.
I'm going to use where T equals 1, where T equals 2, and where T equals 5. Everybody see that? Okay, so let's do that. So I have 10,000 divided by 5 plus 1245 E to the negative 0.97. How come I didn't plug in the 1? Why didn't I plug in the 1 with the exponent?
1 times negative 0.97
Is negative 0.97. Good.
21.
Exactly?
Yeah.
Okay.
Oh, not exactly. I rounded it. Like it was 20.966.
Yeah, I got 20.966, something like that, yes?
Yeah.
So if I'm finding the number of people infected, about how many people were infected from this disease after the first day?
21.
About 21. Okay, so now let's go. And I'm going to do the exact same problem. I'm going to evaluate where T is what?
2.
Mm-hmm. Okay, I got about 54.37. So how many people is that about?
54.
54. And now we're going to evaluate after how many days?
5.
5. So 10,000. Do you guys, I understand some of you are just sitting here just watching along. If you don't know how to put this in your calculator and most of this stuff is just calculator work, there's not much partial credit I can give you. So if you don't know how to put it in the calculator, you need to figure it out now and ask questions. Okay, this is about 678.134. How many people is that about?
678.
678. What do you guys notice about these numbers from day 1 to day 2 to day 5?
They're getting very
They got bigger. In a hurry or slowly?
hard.
In a hurry. So guys, when you have exponentials, when you have exponential functions, they get big in a hurry. Curvins, you good? Is he showing you? Okay, perfect. All right, here we go. Find the number of people infected. Whoops, same thing. All right, now we're going to talk about interest. You guys have seen this before. This is really easy. When we talked about compound interest on our first section, remember we talked about monthly, quarterly, daily, that sort of thing. This is when you have interest compounded continuously. As soon as you see compounded continuously, I want you to think about our friend APERT. Okay? All of this stuff is the same, except now you don't have the n. You don't have the number of years where you have to plug in 1 plus whatever. If it says compounded continuously, you think of APERT. P is your principal. It's the amount that you start off with. Our interest rate has to be in what? Before we can calculate it, it's got to be a what? A decimal. Good. Got to be a decimal. And number of years. Continuous is a PERT. I'm going to say that a million times. If I look at this, I got one example and then we're done. It says right here, find the amount of interest compounded continuously. What do I remember when I see compounded continuously? What did I just tell you? All right, my friend, a PERT. A PERT. RT is your exponent. So principal, what is the amount that I started off with? $1,000. What letter comes now? E. And then in the exponent, I put the interest rate times the time. What is the interest rate, guys? It's 12%. So how do I use that in my calculator? 0.12. And how many years?
3.
So I say 3 times 0.12. Put all of that in your calculator. That's a times sign. It's not an X. So it's 1,000. Hit second E, and then in parentheses, 3 times 0.12. And what do you guys get? 1433.33. Guys, we're talking about money. So round it to dollars and cents. But does that make sense? Anytime you see continuously, the formula you use is a PERT. I'm not going to give that to you. You need to know it. Compounded quarterly, monthly, semi-annually, that's when we use the other interest formula. But when it says continuous, we think about our friend who? A PERT. Good.